High-performance liquid chromatography is a foremost form of liquid chromatography to separate components of a mixture. In high-performance liquid chromatography, the sample mixture is dissolved in a solvent, which is a mobile phase, and under a high temperature is then forced to flow through the chromatography columns. In the column, each component of the mixture interact differently with the stationary phase, resulting in the separations to occur. The molecule that interacts strongly with the stationary phase will move slowly through the columns, while the molecule that interacts less strongly will move rapidly through the column. High-performance liquid chromatography can be classified by various factors. In this experiment, reverse phase partition chromatography is used. It utilizes a polar mobile phase in combination with non-polar stationary phase. Its mobile phase is water and acetonitrile. Its stationary phase is C18 chemical.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sharifun Razia binti Syed Shuharman. Today I will talk about the methodology of HPLC. The instrument used in HPLC is Perkin-Elmer Series 200. In step 1, for caffeine standard solution, in stock solution was dissolved in distilled water, then make up to volume with distilled water. In working solution, 0. mg per ml is labeled as solution B. 1 ml of solution A was pipetted into a 10 ml volumetric flask and make up to volume with distilled water. For step 2, in sample preparation, about 10 ml of soft drink sample, which is Coke Pepsi 100 plus, was poured into a small beaker. A magnetic stirrer was used to remove any carbonation, can be sonicated if necessary. Then 2 until 5 ml liquid was 0.5 micrometer diameter membrane filter to remove particulate matter. Step 3, 10 microliter solution B was injected into the HPLC to establish the retention time of the caffeine. For the step 4, the area of the caffeine was measured. For the step 5, 10 microliter of the prepared soft drink sample was injected into the HPLC instrument. For the last step, the peak area was measured corresponding to the caffeine by referring its retention time.
From this experiment, the RF for caffeine standard is 4302234.6, while the concentration of caffeine is 0.56 ppm. The stationary phase is a polar, while the mobile phase liquid is non-polar since it was a reverse phase partition liquid chromatography. The retention time of analyte decreased because of strong eluent strength. The amount of caffeine in soft drink sample was determined. The peak for the graph of caffeine standard was 1.514 and the average peak for the Coca-Cola is 1.529. This shows that the Coca-Cola contains caffeine in its ingredient.
We can conclude that the retention time for a standard solution that is caffeine is 1.514 per minute. The caffeine peak in a soft sample are, the first one is 2725914 and the second one is 236769495. The third one is 2147035. Lastly, the amount of caffeine in a soft drink are 0.56 ppm. That's all.